Cyborg is a hybrid of man and machine. Over the last few decades, prosthetic limb technology has progressed at an incredible speed, and 3D printing has made bionic body parts relatively accessible as well. But the real evolution in cyborgization was the new technology discovered last year by researchers at MIT. It allows you to feel the robotic body part like a real one, not just giving feedback, but also feeling the position of the prosthesis in space. The Neuro-Embodied Design project is led by Professor Hugh Herr at MIT, who himself has lost both his legs. Under his leadership, an agnostic-antagnostic myoneural interface was developed, abbreviated AMI, which connects the nerves in the residual limb to the external bionic prosthesis and allows you to feel it as a full body part. It is this feeling of unity with its means of rehabilitation, the boundary, that turns a man into a cyborg, the professor believes. The new neural interface and communication paradigm are able to send movement commands from the central nervous system to the robotic prosthesis and transmit proprioceptive feedback describing the joint movement back to the central nervous system. The technology also includes a special surgical technique that closes each muscle pair of an agonist. Interestingly, Hugh Herr sees the application of technology not only for rehabilitation, but also for the empowerment of the individual. For example, to create real wings, which the carrier will also feel as part of the body and manage them intuitively. The idea of empowering the human being with advanced prosthesis is not new. For example, James Young, having lost his hand, developed together with the Japanese company Konami Bionic Hand on the model of his favorite computer game Metal Gear Solid. The hand includes its own drone, the lighting of which James can change according to his mood, laser, flashlight, USB port for charging the phone, sports watches, and most importantly, the hand itself, which responds to messages sent by his muscles. Drummer Jason Barnes also lost his hand, but did not part with his muscular career. His prosthesis has two built-in drumsticks, one of which is controlled by a sensor that reads the electromyogram from the muscle, and the other is controlled by an artificial intelligence and improvised, adjusting to the first stick. The beat rate allows James to be the fastest drummer in the world at 20 beats per second. Jason also has a single stick prosthesis and a bionic hand that allows him to learn to play the piano. Rob Spence is a director with a cybernetic eye that records everything he sees. To realize the idea, we had to place a wireless camera in the cavity with a 9x30 by 28mm parameters. As a result, a former employee of MIT and SpaceX engineer Costa Grammatis was able to literally squeeze in 8 square millimeters, not only the camera itself, but also the battery with a signal transmitter to an external device as well as a board for image processing. The charge of such a camera is only enough for half of an hour, but it does not prevent Spence to shoot it on his movies. In other countries, like Russia, cyborgization is moving forward. The most advanced bionic prostheses are made by Max Bionic, which specializes in hand and Morotica, which creates a highly functional prosthesis for adults and children. But it's not just by wearing the prosthesis that you can become a cyborg. The next level is to introduce chips into the brain, or the head, or the spinal cord. Such implants allow you to move and feel the world with paralyzed limbs, replacing the missing feelings of nature and create new ones. And that is not fantastic. The first paralyzed person who was able to move his limbs again was Ian Burkhart, who broke his neck at the age of 19. Scientists took a functional magnetic resonance image of Ian's brain while he focused on a video of his hand movements and identified the responsible part of his motor cortex. It was implanted with a chip that reads the activity of the area of the brain, converting and transmitting the signal through a cable to a computer. This information is then sent as an electrical signal to the flexible sleeve around the subject's right arm, and it stimulates the muscles. Recently, American scientists created a neuro interface that allowed a patient with spinal cord injuries to not only control the movements of his paralyzed hand, but also to feel the grip and regulate its power. Weak residual sensory sensitivity was found in the primary motor cortex and is enhanced by a feedback system. Brain implantation can also change perception of reality. In 2003, Neil Harbison was implanted with a sensor in his head that allows him to hear color by determining the frequency of the color in front of him, translating it into sound, and transmitting sound through bone conduction to his brain. Harbison says that this connection between color and sound soon became a perception, allowing him to dream about color, and at this point he feels that software and his brain have merged. Besides the normal spectrum, Harbison can also perceive infrared and ultraviolet light. But most engineers see the ultimate goal of brain implants not in return of the lost feelings and abilities, but empowering the brain by connecting it to a computer, i.e., merging with artificial intelligence. The most famous project in this area is Elon Musk's Neuralink company. Neuralink, or more precisely, neural lace technology, consists of a nanogrid of electrodes that integrate with the brain, allowing it to transmit and receive digital information